In this lesson, I'll be taking you through a tool called hanger diagrams to help us do a process to solve equations. So on the left here, you're going to see a hanger diagram. What you're going to want to notice is that it looks like both sides are evenly matched because the hanger is not leaning to the left or leaning to the right. So we can use an equation to model this diagram. On the left, there are 7 ones, so we're going to write 7, and it's equal, it's balanced. On the right, we have 3 W's and a 1. We're going to call that 3W plus 1. Now, our task is to figure out what W is, and a lot of you can do that mentally, but I want to show you how this diagram relates to a process that we're going to use over and over and over throughout this year. So the first thing you want to do is kind of look at what you have in common on both sides and see what you can get rid of or eliminate. We have a 1 on both sides, so I can cross that off. Crossing it off in math, that's the same thing as we're taking it away. So I like to show that I'm taking away 1 from each side. And it's pretty common for me to draw a line down this equal side, so I know that I'm doing it on the left and on the right of that equal sign. Then I like to say what's left over. So it looks like on the left, I still have 6 ones, and on the right, I have 3 W's. Now our task is to figure out what's the value of 1 W. So in this case, we have 3 W's left, so we want to kind of split this side into 3 equal groups. But if I do that on the left side, I also need to split the right into 3 equal groups. And it looks like in each of my groups, 2 ones are equal to 1 W. I would show that in math, that splitting into equal groups, as the operation division. So I'm going to show that I divided both sides by 3, and then I left an answer of 2 equals W. Okay, now you always want to go ahead and check if you're right. So you're going to see if 2 really does equal W. You would plug a 2 in for these W's. If you notice that you have 2, 2, 2, and this 1, there's a value of 7 over here. And on the left, there's also 7. And I'll show you how to do that algebraically as well. We would plug 2 in for W here and see if 7 really equals 3 times 2 plus 1, following the order of operations. 3 times 2 is 6, 6 plus 1 is 7. So it looks like both sides end up matching. Okay, let's look at a second example. So this one's pretty similar. Again, the left and the right side balance, so we can write an equation. So my equation in this case, it looks like on the left I have 3x plus 2, and on the right that equals 3. So I'm going to start right away this time by drawing a line down the middle of my equal sign. And then I'm going to start trying to simplify this as much as I can. So I'm going to take 2 of these boxes away from the left side, but if I do it on the left, I need to also do that on the right. So algebraically, I show that I subtracted 2 from both sides. Now what's left? On the left-hand side, I still have 3 x's, and on the right-hand side, I only have 1. Now I want to figure out what's the value of 1x. Well, there are 3 x's, so to get just one of them, I'm going to split that into 3 groups, which looks pretty easy on the left, but notice on the right, I only have this one block. How am I going to split that into 3 groups? Well, I'm going to have fractions this time. So I'm going to divide both sides by 3. 3x divided by 3 is just 1x, and 1 divided by 3, that leaves me with 1/3. Again, let me go ahead and check my solution. Okay, so if I put 1/3 in for each of these x's, these 3 1/3 add up to 1. I have 2 more 1s over here, so I have 3 on the left side, and I also have 3 on the right, so both sides match. All right, so whenever we're solving equations, these are our goals. You're trying to get the variable alone. Whatever you do to one side, you have to do it to the other to keep it balanced. We like to use the reverse order of operations to undo, and you always check your answer. We're going to do this over and over again until you get to be an expert at this process.